So what we have here is our equipment for making dry ice in the laboratory. It was funded by the Blackhawk College East Foundation in 2014, and it allows me to make small quantities of dry ice in the laboratory, which I can't get locally around here in any stores. There's a tank behind me that's got carbon dioxide in it under very high pressure, and when I open the valve, it releases the carbon dioxide, which cools down rapidly because the pressure decreases so quickly. And at atmospheric pressure, what we have in the air around here, carbon dioxide forms a nice solid we call dry ice. And so it allows me to collect the dry ice. So here's how it works. Hopefully that will be enough for my purposes today. I just have to take apart this blue chamber, and it's a little difficult to see, but very small quantities of dry ice have set in at the ends, and if I go long enough, I can fill this whole chamber with dry ice. Often I only need just this small quantity that I have in this chamber. So the uses for carbon dioxide are a lot, or dry ice, I should say, in the lecture. So I've got a few examples here. One is I've got a container, a little plastic container, and I can throw the dry ice in there. Okay, and dry ice, of course, has this fantastic property that it's always a solid or a gas, but never a liquid. That's why they call it dry, and it looks fascinating that something never ever melts. Well, the teaching advantage to this is you can show what the conditions are for something to melt. So what I do is I just put this into a tube and let it sit. I think I might let it sit at a distance, and it'll take a little time, but as the carbon dioxide goes into a gas, it builds up pressure on the inside, and it's the pressure that allows things to go into a liquid state. If CO2 gets high enough pressure in there, it'll turn into a nice liquid. This helps us illustrate things about phase diagrams and physical properties, but also in more recent years it turned out that liquid CO2, if you can put it at high enough pressure, turns out to be a really good solvent for lots of chemical experiments. It's one of these that will let molecules of different kinds of compounds dissolve in there, and then when you're all done with the CO2, you just let the pressure go and it completely goes away, and it doesn't hurt anything. It's been proposed, hasn't been very successful for technical reasons, as a great dry cleaning solvent. You can put your clothes in a very high pressure washing machine filled with dry ice, and it'll go to liquid, and it turns out to be a really good solvent for things that you might take to a dry cleaner. So it's starting to get wet, it's starting to condense down, the pressure's going up, and as soon as it gets high enough, it has to get above something called the triple point. Once it gets higher than the triple point pressure, we're in good shape. We're going to have some liquid carbon dioxide. Okay, there it goes. At the risk of boring you, I'm going to let it go. I can mention another comment or two. If you were to take this container and put it in its thin wall variety, the thin wall variety is when it's actually made into a big 2-liter container, it'll blow up, and it'll cause a lot of harm, And look on YouTube, you'll see people doing that. People get harmed from these blowing things up. This happens to be the same container before it gets blown into a 2-liter bottle. Very thick walled, very tough, and so that's why it's not blowing up. But needless to say, you have to be careful with this. I've got my safety goggles on, and there it goes. It's going into a liquid. Now it'll go all the way into a liquid. I don't know that I want to wait for it to go all the way into a liquid. Well, maybe I'll give it a little more time. And the pressure is getting quite high, right? Now, of course, if the pressure gets released, it's below its triple point, it can no longer form a liquid. It's only a solid and a gas. So at some point, yeah, maybe now, I'll give that a try. Let's see if we can do that. Okay, not too exciting, but it's better than an explosion. It's gone right back to the solid state once I relieved the pressure. Okay, so let's do another example. We also like to show the properties of dry ice in other ways. Okay, in this case I've got a little container. It's a little mesh wire container, and the only reason I'm putting the dry ice in there is because it'll sink to the bottom of this thing. Okay, beautiful. Now, one of the things we get from this is that the dry ice is so very cold. It sublimates at negative 200 degrees Celsius approximately. It will not get above that temperature until it's all sublimated away. So it represents a very cold thing. We like to get our Omaha steaks nice and fresh by putting dry ice in the packages to send them around. Now, it's also true if I put some yellow coloring agent in here. This is called bromethymol blue. I'm going to try to do it before the dry ice is all gone. It turns a nice yellow color, indicating to us that carbon dioxide is an acid. This is always yellowish in acid, but if I put some base in there, if I neutralize the acid, I get a nice color effect. Maybe it's hard to see. There we go. A nice blue color effect that'll go away as the carbon dioxide neutralizes the base and it comes back to the yellow color. This, in fact, is a nice laboratory experiment. It's also a nice example of why carbon dioxide is so important in the atmosphere and other places, because it has a tendency when it builds up, like it's been building up from all our burning of fossil fuels, to make natural waters acidic. And so there's a concern there for the health of coral and other aquatic life. Okay, last on our dry ice agenda is this bowl, this sponge bowl with some warm water in the bottom. And what I'll do is I'll throw some dry ice in there, okay? And the dry ice will just warm up and sublimate. Now when it sublimates, what it's giving us is carbon dioxide gas. Dry ice is carbon dioxide solid, and now we've got carbon dioxide gas. And I'm going to let the carbon dioxide gas build up. Hopefully you can see that it's a milky color. That's because it's so cold, it's causing water vapor in the air to condense, just like a cloud. Okay, right next to it is a candle, and here's where we're going to go with this. It turns out that carbon dioxide in and of itself has some interesting properties. One of the ones we like to illustrate is density. If I let this thing sit in there, it'll build up carbon dioxide to such a point that it'll fill pretty much the whole bowl with carbon dioxide. I'm just trying to get it to go a little bit faster here. That ends up being a very important property of carbon dioxide. The gas, when it's a gas, is actually heavier than air. And you can see it building up in there, but not going over the edge. And lots of interesting effects. I like this one. I'll try to blow some bubbles in there. The bubbles have air in it, and the carbon dioxide is there on a layer on the bottom of the bowl. I missed. Okay. Maybe you can see the bubbles are actually floating on top of the carbon dioxide, showing that the carbon dioxide is heavier, and then the air are more dense and the air is less dense. In this situation, you can also literally scoop the carbon dioxide gas as if it were a liquid. I'll try to do that and show its other property, that it is a very good fire extinguisher. And fire extinguishers made with carbon dioxide are often used.